Welcome back. This is your quick revision for the CBSE Class 10 board, Light, Reflection, and Refraction, in about 12 minutes. Not the whole textbook, just the minimum you need to score. And here is what this video covers year by year. From 2022 to 2026, 97% of every light question that came on the CBSE Class 10 board. 2022 and 2024 were 100% covered. If you only have 12 minutes, these are the right 12 minutes. Let's go. Start with reflection. 2 laws. The angle of incidence equals the angle of reflection, and the incident ray, the reflected ray, and the normal all lie in the same plane. Spherical mirrors. A concave mirror curves inward and converges light. A convex mirror curves outward and diverges it. The center of curvature is C, the focus is F, and the focal length is half the radius of curvature. F equals R by 2. To locate a mirror image, use any 2 of these rays. A ray parallel to the axis reflects through the focus. A ray passing through the focus reflects back parallel to the axis. And a ray through the center of curvature retraces its own path. Where the rays meet is the image. For a concave mirror, the image depends on the object's position. At infinity, a tiny real image at F. Beyond C, a real, inverted, smaller image between F and C. At C, real, inverted, same size, at C. Between C and F, real, inverted, larger, beyond C. At F, the image is at infinity. And within F, a virtual, erect, enlarged image behind the mirror. A convex mirror is simple. Wherever the object is, the image is always virtual, erect, and diminished, formed behind the mirror between the pole and the focus. That's why it gives a wide field of view. The mirror formula links them. 1 by V plus 1 by U equals 1 by F, and magnification, M, equals minus V by U. Notice the mirror formula uses a plus. Refraction is the bending of light as it changes medium. Going into a denser medium, light bends toward the normal. The refractive index, N, equals C by V, the speed of light in vacuum divided by its speed in the medium. Lenses. A convex lens is thicker in the middle and converges light. A concave lens is thinner in the middle and diverges it. The lens formula, 1 by V minus 1 by U equals 1 by F. Magnification, M, equals V by U. For lenses, 3 rays. A ray parallel to the axis passes through the focus on the far side. A ray through the optical center goes straight, undeviated, and a ray through the focus emerges parallel to the axis. For a convex lens, object beyond 2F gives a small, real, inverted image between F and 2F. At 2F, same size at 2F. Between F and 2F, a large, real image beyond 2F. At F, the image is at infinity, and within F, a virtual, erect, magnified image on the same side, the magnifying glass. A concave lens, like a convex mirror, always gives a virtual, erect, diminished image on the same side as the object, no matter where the object is placed. The power of a lens is won by its focal length in meters, measured in dioptres. A convex lens has positive power, a concave lens, negative. Now lock them in. A few tricks. Say them with me. 1, the big one. The mirror formula adds 1 by V plus 1 by U. The lens formula subtracts 1 by V minus 1 by U. Mirror adds, lens subtracts. 2. Signs. Distances are measured from the pole or the optical center. Anything in the direction of incoming light is positive, against it is negative. For a concave mirror, F is negative. Convex mirror, positive. Convex lens F is positive. Concave lens, negative. 3. Magnification. For mirrors, M equals minus V by U. For lenses, M equals V by U. Mirror has the minus. 4. Convex bulges out and converges light. That gives it a plus sign. Concave caves in and diverges light. That gives it a minus sign. Bulges out, plus. Caves in, minus. 5. Power equals 1 by F in meters, in dioptres. Convex positive, concave negative. A shorter focal length means more power. 6. Refractive index N equals C by V. Higher index means a denser medium, slower light, and more bending toward the normal. Now pause the video, cover the screen. Can you say them from memory? That one act of recall is worth 10 rereads. Before the questions, here is how to actually solve any light problem on the board. 5 steps. The same 5 every time. Step 1. Draw the diagram, even if not asked. Place the mirror or lens. Place the object. Mark F. Mark U. Mark V. The numbers stop being scary when they are on a picture. Step 2. Signs. The pole is your origin. Distances measured against the direction of incident light are negative. For a concave mirror, U and F are negative. Get the sign right, and the formula does the rest. Step 3. Pick the formula. Mirror, 1 by V plus 1 by U equals 1 by F. Lens, 1 by V minus 1 by U equals 1 by F. Magnification, M equals minus V by U for mirrors, V by U for lenses. Step 4. Substitute, then solve. Show every line. Examiners give marks for steps, not just the final number. Skip a step and you leave marks on the table. Step 5. Check the sign of V. Negative V means real and inverted. Positive V means virtual and erect. Then check the unit. Centimeters or meters. Be consistent. For MCQs, eliminate. 2 options are usually clearly wrong. From the remaining 2, pick by the sign convention or by the image formation table. Never guess randomly when you can rule things out. For 3 and 5 mark questions, structure your answer. Definition, formula, diagram if relevant, substitution, numerical answer with unit, 1-line conclusion. That structure is what examiners reward. These are the questions most likely to appear, ranked from years of CBSE papers. 1. Mirror formula. A concave mirror of focal length 15 centimeters, object at 20 centimeters. With signs, F is minus 15, U is minus 20. 1 by V equals 1 by F minus 1 by U, which gives minus 1 by 60. So V is minus 60 centimeters, a real inverted image 60 centimeters in front. Magnification is minus V by U, which is minus 3. 2. Lens formula. A convex lens of focal length 10 centimeters, object at 15 centimeters. F is plus 10, U is minus 15. 1 by V equals 1 by F plus 1 by U, which is 1 by 30. So V is plus 30 centimeters, a real inverted image. Magnification is V by U minus 2. 3. Power of a lens. A convex lens of focal length 25 centimeters. That's 0.25 meters. Power equals 1 by F, which is plus 4 dioptres. 4. Refractive index. Glass has a refractive index of 1.5. Speed of light in glass equals C by N, 3 times 10 to the 8 by 1.5, which is 2 times 10 to the 8 meters per second. 5. A case-based favorite. Why is a convex mirror used as a vehicle's rear view mirror? Because it always forms an erect, diminished image, and it gives a much wider field of view than a plane mirror. 6. Ray diagram. For a concave mirror with the object beyond C, the image forms between F and C. It is real, inverted, and diminished. Use 2 rays, one parallel to the axis reflecting through F, and one through C reflecting back on itself. 7. Ray diagram. For a convex lens with the object beyond 2F, the image forms between F and 2F on the other side. Real, inverted, and diminished. One ray parallel to the axis bends through F, one straight through the optical center. 8. A ray passing through a rectangular glass slab bends toward the normal entering and away from the normal leaving. It emerges parallel to the incident ray, just shifted sideways. That sideways shift is the lateral displacement. Now your turn. 4 quick questions in the CBSE style. Solve each one yourself, then check. Active recall is how it sticks. Question 1. Which mirror is used as a car's rear view mirror, and why? A convex mirror, because it gives an erect, diminished image and a wider field of view. Question 2. A convex lens has a focal length of 20 centimeters. Find its power. Power equals 1 by F in meters, 1 by 0.2, which is plus 5 dioptres. Question 3. Assertion. A convex lens can form a virtual, erect, magnified image. Reason. This happens when the object is placed within the focal length. Both are true, and the reason correctly explains the assertion. That's the magnifying glass. Question 4. What kind of image does a concave lens always form? A virtual, erect, and diminished image, no matter where the object is. 60-second mind map. Mirror formula adds. Lens formula subtracts. Magnification. Mirror minus V by U. Lens V by U. Power is 1 by F in dioptres. Refractive index is C by V. Convex converges and is positive. Concave diverges and is negative. Cover the screen and say them all. Then watch this again tomorrow, next week, and the night before the exam. Spaced repetition beats cramming. You have got this. Subscribe, and I'll see you in the next chapter.